Hello everyone, welcome to all. In this lecture, we'll discuss about insertion sort technique. The main idea of insertion sort is like sorting a hand of playing cards. How we sort playing cards in our left hand is nothing but the insertion sort technique. Let us see how insertion sort sorts a given set of elements in this manner. So start when we take playing cards into our hand, how we sort, we'll start with an empty left hand and the cards facing down on the table. One by one we'll pick the cards. So remove one card at a time from the table and insert it into the correct position in the left hand. That means compare this card with each of the cards already in the left hands from the right to left. We'll compare. And the cards held in the left hand are already sorted. We pick one card from the table and we'll compare this card with each card in the left hand and we insert that card in its proper place. Generally, the card, whatever card we pick from the table is the topmost card from the pile of cards. Always we pick the top card and insert into its proper place. That's how we sort or arrange the playing cards in the order. Insertion sort technique follows the same mechanism. Let us take an example how we sort playing cards. Assume that in our left hand we have 4 cards with numbers 6, 10, 24, 36. Of course, 24, 36 are not available in playing cards. Okay, so just for example, assume that these are the 4 cards already in the left hand. And if you observe, these cards which are in the left hand are already in sorted order. Now the next top card is card with the number 12. This card we need to insert in this left hand. So generally what we do, we compare starting from the rightmost card. Okay, so whether 12 is less than this, yes. Okay, so that means we assume that it should go to the left of 36. Then we'll compare the next card. 12 is less than 24, yes. So it should go to the left of 24. 12 is less than 10, no. Okay, so that means the card 12 should be inserted between 10 and 24. This is the position of the card 12. So what we do, we create room for a 12 here like this. We move this rightmost card one position to the right, then next card one position to the right, and we create a space for this new card to be inserted. Then we insert this new card in that position. So this is how the element will be inserted into its proper position. Our insertion sort techniques follows the same method. So first, let us understand the insertion sort algorithm. Let A is an array containing a list of n numbers. Suppose these n numbers in the array, A of 1, A of 2, up to A of n. Okay, so are stored inside the memory. The first number will be stored at A of 1, second number will be stored at A of 2, and the last number is stored into A of n. Okay, and all these numbers or the array of n elements is in memory in this manner. Now, the insertion sort algorithm working principle we'll discuss now. So, how it works? The insertion sort algorithm scans A from A of 1 to A of n. That means from left to right, it scans, inserting each element A of k. Assume A of k is the element to be inserted. Okay. And this element is inserted into its proper position in the previously sorted subarray A of 1, A of 2 up to A of k minus 1. Assume that A of 1, A of 2 and A of k minus 1 are already the sorted subarray. Now, the next element is A of k, and this A of k is the element to be inserted into this. And the insertion sort algorithm, what it does, it scans from A of 1 to A of n, and this A of k will be inserted in this subarray, which is already sorted into its proper position. As in previous example, we have seen how 12 is inserted in its proper position. In the same way, A of k is inserted into its proper position in this sorted subarray A of 1, A of 2 up to A of k minus 1. Okay. So, step by step mechanism we'll try to understand. That is, in the first step, what it does is the first element, one by one element, it has to arrange in the sorted order. Okay, so A of 1 by itself is sorted. That means in the first step, the first element, there is only one element, that is A of 1, which is already sorted, we assume. Then the second step, A of 2 is the element to be sorted. Okay, so this A of 2 is inserted either before or after A of 1. So that A of 1 comma A of 2 is sorted. That means in the second step, the element to be sorted is A of 2, and already A of 1 is already sorted. Now A of 2 can be inserted either before A of 1 or after A of 1, such that when you arrange in this fashion, such that A of 1 comma A of 2 is sorted. Then in step 3, A of 3 is inserted into its proper place in A of 1 comma A of 2, because these are the two elements, A of 1, A of 2 already sorted, and A of 3 is to be inserted into its proper place. That is, what is the proper place for A of 3? It can be inserted before A of 1 or between A of 1 and A of 2 or after A of 2. And if we arrange in one of these places, so that A of 1, A of 2, A of 3 is sorted. So we have to insert the next element A of 3 into its proper position, so that A of 1, A of 2, A of 3 is sorted. So this way, each element will be inserted into proper position, so that the previous subarray is sorted. Now, in the next pass, the next step, A of 4 is the element to be inserted into its proper position. Okay, so we pick this A of 4 and it has to be inserted into its proper place. Okay, so in which elements we insert this in A of 4? A of 4 has to be inserted in A of 1, A of 2, A of 3. Okay, so that if you insert, then A of 1, A of 2, A of 3, and A of 4 is sorted. And what is the place for A of 4 to be inserted in these three elements, A of 1, A of 2? You can insert either before A of 1 or between A of 1 and A of 2 or between A of 2 and A of 3 or after A of 3. In one of these places, we can insert this A of 4. And if we insert in one of these places, so that the array A of 1, A of 2, A of 3, A of 4 will be sorted. So in this way, we proceed to each and every element. We pick each and every element and insert it into its proper position. And finally, when we reach to nth step or nth pass, okay, now the last element A of n is the element to be inserted into its proper place, where in A of 1, A of 2, A of 3 up to A of n minus 1. Okay, so that when we insert A of n into its proper place, so that A of 1, A of 2 up to A of n is sorted. That means now the list A of 1 to A of n will be sorted after n passes, n steps. This is how the insertion sort algorithm inserts, picks each element and inserts into its proper position, so that the list to the left of the element will be sorted. Clear? So let us take an example, numerical example, and we'll try to demonstrate this technique step by step. Now, the question generally will be asked in this fashion. Sort the following numbers using insertion sort. You will be given a set of numbers and you are asked to arrange them in a sorting order using this insertion sort technique. Okay, so we assume that these numbers are stored in an array A containing the elements A of 1, A of 2, A of 3, A of 4 up to A of 8. How many elements are given here? 8 elements are given, and these are the positions of elements in the array. And in the first pass, so I am denoting each pass with the variable k. K is equal to 1 indicates first step or a first pass. Okay, so assume that these are the numbers stored in the array in this fashion. Okay, so we store the numbers in the array in the given order. Okay, this is how the numbers. Now, in first pass, the element, first element is to be sorted. Since there is only, this is the only element because there is no previous sub array for this. So this is the element, and since it is only element, and we assume that the element is already sorted. So 77 is inserted into its proper position. That is what we assume here. Then in the second pass, k is equal to 2 indicates second step or second pass, and because 77 is already sorted. Now, what is the element to be sorted here? A of 2. A of 2 is the element to be sorted. So what is there in A of 2? 33 is the number in A of 2. So this 33 is the number to be sorted. So what we do is we circle this number. Whatever number we are going to sort, you circle that number in each pass. Okay, so k is equal to 2, A of 2 is the element to be sorted. So 33 is the number to be sorted, circle it, so that you will come to know this is the element to be inserted into its proper position in previous sub array. Now, what is the previous sub array? To the left of 33, there is only one element. Okay, so now we have to insert this 33. We have to find a suitable place for this 33 in the left hand side. Okay, so what is the place for this 33? Since we compare this previous element, since 33 is less than 77, that means 33 should come before 77. Okay, so this is the place where 33 has to be inserted. That means it should come before 77. So what we do, because your array begins from A of 1 here. Okay, so we assume that I am assuming the array indexing in the numerical example beginning with a of 1. In actual implementation, the array index begins with a 0. Okay, but for numerical example, for the easy understanding of this insertion sort technique, I am assuming that the array indices begins from 1, 2, 3. Okay, right. So 33 is to be inserted before 77. So we have to create room. That means first 33 should come, then 77 should come in the array. Okay. So what I do is I first move this 77 to A of 2 position. Okay. So that means in A of 1, now I have created room for 33. Now 33 I copy into A of 1 position, so that A of 1 and A of 2 is sorted now. Just see here. So after second pass, the first two elements will be sorted. So now that means what is the insertion sort technique? 33 is the element to be sorted here. So that means 33 is inserted into its proper position here, so that A of 1, A of 2 are sorted. Now I go to the next step. K is equal to 3 indicates that step 3. Okay, so in the step 3, the remaining elements you write as it is in the array. Okay, now what is the element to be sorted? I have shown the element to be sorted in red color. Okay, and just you circle the number to be sorted in this pass. So since k is equal to 3, a of 3 is the element to be sorted. Okay, so now 44 has to be inserted into its proper position in previous subarray. Now, what is the previous subarray? Previous sorted subarray. Okay, so 3377 forms the previous sorted subarray. Now, 44 has to be inserted in this subarray. So, you have to find out what is the best place to insert this 44 in this subarray. So, for that purpose, what we do is we'll compare with each element in the subarray. So, first we compare 44 is compare with the 77, whether 44 is less than 77. Yes. Okay. So then we compare with 33. 44 is less than 33. No, that means 44 should come in between 33 and 77. The position of 44 in this subarray is between 33 and 77. That means we need to insert 44 in between these two numbers, 33 and 77. So that means you have to create room for this 44. So for that purpose, what I do is first 77 will be copied into A of 3 position. Okay, so then A of 2, now see here 33, 77. In between these two, 44 has to be copied. Now I copy 44 in A of 2 position and 33 will remain as it is in A of 1 position. Okay, so after inserting 44, now the sub array A of 1, A of 2, A of 3 is sorted. So you have to insert in such a way that A of 1, A of 2, A of 3 is sorted. Once you do this, then go to the next step. K is equal to 4 indicates step 4 or pass 4. Then you copy remaining numbers as it is. These are the remaining numbers. You copy as it is. Now, what is the element to be sorted? K is equal to 4. A of 4 is the element to be sorted. Then you circle this element to be sorted. Okay. Now, compare this 11 with previous subarray. Okay, so 11 less than 77, yes. 11 less than 44, yes. 11 less than 33, yes. That means what is the position of 11? 11 should come before 33. 11 should come before 33. This is the place where we need to insert this 11 here. That means you have to create room to insert 11 in this position. So for that purpose, what I do, first I move 77 to one position to the right. That means from A of 3, I move 77 to A of 4. Then I move 44 from A of 2 to A of 3. Then I move 33 from A of 1 to A of 2. Now in the first position, A of 1 room is created so that I can copy 11 in this position. Just see here whether, see, 11 is inserted before 33. That means 11, 33, 44, and 77 now are all in sorted order. This subarray is now sorted. Okay, so after inserting 11 in its proper position, the subarray A of 1, A of 2, A of 3, A of 4 is sorted. This is what insertion sort technique is. Now go to the next pass. Next step, K is equal to 5 indicates what? Step 5. Okay, so you copy the remaining elements as it is here. Okay, then identify what is the element to be sorted. Since K is equal to 5, A of 5 is the element to be sorted. Circle this element. So what is the number in A of 5? 88. So 88, you circle is 88. Now this is the number to be sorted. Okay, so since 88 is greater than 77, now this is the position where 88 has to be inserted. That means 88 remains in its own position. Okay, so in previous sub array, okay, now if we insert 88 here itself, then this sub array becomes sorted 11, 33, 44, 77, and 88. That means there is no movement for this 88. 88 will remain as it is in its position in this step. Okay, right? So then go to the next pass. K is equal to 6. K is equal to 6 indicates step 6. Okay, so copy all the elements as it is. Then identify the element to be sorted here. Since K is equal to 6, A of 6 is the element to be sorted. Circle this element. What is the number in A of 6? Location 22. So 22 is the number to be sorted. Okay, so now we need to insert 22 in its proper position in this previous subarray so that this subarray becomes sorted. Now go on identifying its position. Okay, so compare 22 with this previous elements. 22 less than 88. Yes, we can go to the previous element. 22 less than 77. Yes, then go to the previous element. 22 less than 44. Yes, then go to the previous element. 22 less than 33. Yes, then go to the previous element. 22 less than 11. No, false. That means now this is the position where we need to insert a 22. That means in between 11 and 33, we need to insert a 22. This is the proper position of 22. Okay, so that means 22 should come after 11. Okay, so that means in A of 1 position 11 is there and 20 should come to A of 2 position. Okay, so you have to create room for A of 2. For this purpose, what I do is first I move 88 to A of 6 position, 77 to A of 5 position, and 44 to A of 4 position, and 33 to A of 3 position, and 11 will remain as it is in A of 1. Now just see here, room is created, space is created for a 22. Now copy 22 or insert 22 in its proper place such that 11, 22, 33, 44, 77, 88 is sorted. So like this, we pick each element and insert into its proper position so that the array, sub array will be sorted. This is insertion sort technique. Okay, right. Go to the next step. K is equal to 7, step number 7 or pass 7. So copy remaining numbers as it is and identify the number to be sorted or inserted. So A of 7 is the element to be inserted. So what is the number element in A of 7? 66 is the number. So circle this number and this is the number to be inserted into its proper position. Now find out what is the proper position or where this 66 has to be inserted in previous subarray. So for that purpose, what we do is the insertion sort technique follows comparing with the previous elements. 66 less than 88, yes. Then go to the next previous element. 66 less than 77, yes. Then go to previous element. 66 less than 44, no, false. When you get a false condition, stop here and this is the place. That means between 44 and 77, the place where we need to insert 66 here. Okay, so that means we identified the proper position of 66 where we need to insert. Okay, so now create room or space to insert 66 in its proper position. So for this, I move 88 to A of 7 and 77 to A of 6. Then this 11, 22, 33, 44, they remain as it is in their positions. Okay, so now I have created space for 66. Now copy 66 or insert 66 into its proper position so that 11, 22, 33, 44, 66, 77, and 88 are sorted. Then go to the next step. A is equal to 8 indicates step 8 or pass 8. and the next element is 55, and this is the element to be sorted. Circle this number and identify its proper position. Okay, so where this 55 has to be inserted in the previous sorted sub array. So compare with 88, 55 less than 88, yes. Then go to previous element, 55 less than 77, yes. Then go to previous element, 55 less than 66, yes. Then go to previous element, 55 less than 44, no, stop. That means this is the place between 44 and 66, 55 has to be inserted. Now this is, we identified the proper position of 55. Okay, so now create space for a 55. So for this, move 88 to A of 8 position, 77 to A of 7 position, and 66 to A of 6 position. Then now you can copy A of 5 position, this 55. Okay, so then these remaining numbers 11, 22, 33, 44 will remain as it is in their positions, and 55 will be inserted into A of 5 position, such that now you can see this sorted array. Then the final array will be sorted after 8 steps, because there are 8 elements and it takes 8 passes or 8 steps to arrange these numbers in sorted order. Now finally in the array, if you print this array, you can see the numbers arranged in the sorted order: 11, 22, 33, 44, 55, 66, 77 and 88. This is how the insertion sort algorithm works to sort a given set of numbers. Now let us see the program which works exactly the way we discussed. In the array, if you store the numbers, and your program should do the same kind of operations in the array. Okay, so let us take the program and we'll see execution of this program. Now this is the insertion sort program which I have already written. You can go through the program here. So inside the main, I have declared an array of size 25. You can increase the size up to 50 or 100 as per your requirement. Then a temporary variable and two loops control variables I and j, and a number of elements to be stored in I have declared in this. Okay, so I'm asking the user to enter how many numbers in the array. Then I'm reading elements into the array. So I'm printing before sorting how the numbers are arranged in the array. I'm printing the numbers before sorting the numbers. Then I'm implementing a implementation insertion sorter algorithm here. These are the steps for implementation of insertion sort algorithm. Okay, so I have written a piece of code which works exactly as we discussed, or which performs operations in the array as we discussed. Okay, right? So this for loop up to here, then it interchanges numbers and arranges the sub array in the sorting order in each iteration. Okay, so this for loop I starts from 1 here. Why? Because a of 0 is already sorted. Okay, so I'm going from second element onwards, and I'll arrange all the remaining numbers in the sorting order using insertion sort technique. That's why I started this array for loop from I is equal to 1 onwards, thinking assuming that I is equal to 0, A of 0 is already in sorted order. Now after sorting, this loop repeats for a and arranges the number in a sorted order. Okay, so if you have n elements, and n elements will be, the last element will be stored in n minus 1 position. No, okay, so it also arranges the last element in sorted order. And after sorting, I'm printing the array here. Okay, so this prints the array in sorted order, this for loop. Okay, so let us see the execution. What I do is I open online compiler here. Just let me open online C compiler. And when you type in Google online C compiler, this first link you can open. And this is online C compiler available. Just copy your code here. And this is our insertion sorter implementation in C. Okay, so let us run this code. Yes, so no errors. Okay, so now it is asking enter how many numbers in the array. Okay, so how many in a previous example we have 8 numbers. Okay, so I'm taking 8 elements of array, and in the given order 77, 33, 44, 11, I enter the same input here. So 77, 33, 44, 11. Okay, so then 88, 22, 66. 88, 22, 66, and 55. Okay, so these are the 8 numbers we need to sort. Okay, so now you can just see here, before sorting the array elements 77, 33, 44, 11, 88, 22, 66, and 55. And after sorting the array elements 11, 22, 33, 44, 55, 66, 77, and 88. That means using insertion sort algorithm, the numbers are arranged in a sorted order in the array. So this is insertion sorter program. So in the next video, I'm going to explain step-by-step execution of this program. You may be having a doubt that how this code arranges those numbers in sorted order. What is happening? Okay, so step-by-step execution with the array diagram, I'll explain in my next lecture, and we can see execution of this program, step-by-step execution of this program. And finally, when we print a array, how the numbers are arranged in sorted order, we can understand. Okay, so through array memory diagram, I'm going to explain in my next video. Thank you all. If you like this video, subscribe to my channel, and please click like button.